Hi everyone. So hopefully you've just watched the video on how to describe a hydrograph. If you haven't watched that one, do watch it first. It's going to improve your understanding of this. You can see that I've annotated the graph and we will have scored half of the available marks in the question by learning how to effectively describe these. The next question we're going to focus on is this one, suggesting reasons why the changes that have occurred in the river's discharge have taken place. Now, I'll just repeat myself very briefly. This question is from the 2019 paper. If you want to go to the SQA website yourself, you can download that and download the mark scheme too, which is a very valuable way and method to revise. Okay, just looking very briefly at this graph. You can see in the graph that there are periods of time along the bottom of the graph, remember, where the river is filling up very quickly. I discussed that in the first video. And some areas where it is filling up more slowly. And I discussed that in the first video. So in other words, we've got a period of time, let's just broadly say between 10 o'clock and 6 o'clock, where the river is filling up more slowly, and a period between 6 o'clock and 2 o'clock where it's filling up more rapidly. Essentially, what the examiner wants you to do here is to demonstrate your understanding of what factors influence the speed at which the river fills. They have designed the question in order that you can explain why the river is filling rapidly, but also they have actually opened the door for you to maybe be able to explain why some parts the river also was filling more slowly. So let's deal with the reasons why the river's filling more rapidly first. I'm a big believer in keeping things simple, and if you want to go through your class notes, you'll see that you've got lots and lots and lots of possible reasons to draw upon. But I want to demonstrate how straightforward this can be. Remember, we've already scored 5 out of 10 for the descriptions that we've done. So now we need a 6 out of 10. 60%, that's closing in on a B. That's really good. So the first thing that I would point out is that if we look back at the question, there is nothing in the question that says that indicates we are not in an urban area. I'll just give you a minute to check that for yourself. Flood hydrograph of the River Lerry, West Wales, 8th and 9th of June. There's nothing that says it's not an urban area. So I'm immediately going to say, could be an urban area. Explaining rapid discharge between 6 o'clock and 2 a.m. and we need to explain why that's valid. Concrete streets are impermeable and so infiltration cannot occur. So surface runoff is reaches the river more quickly. Tick. Immediately, you're now, with just a further little bit of revision and work, we're staring at an answer now that we could easily produce an A from quite rapidly. because we've already scored 5 marks of description. A 6th plus a 7th mark is definitely going to get us up into that bracket where we start to score an A. Why is this a mark is a sensible question for you to be asking. First of all, you've clearly defined what it is that you're explaining. It could be an urban area which explains the rapid discharge. I'm thinking to myself, where is that rapid discharge? Can you demonstrate that to me? Well, yes you can. You've said there's rapid discharge between 6 and 2 a.m. 6 o'clock in the evening, sorry, and 2 a.m. Now you've probably already pointed that out in your description section of the answer, but it does no harm just to slightly repeat it here. Immediately, if you stop there, I'm going to give this symbol and say, you've not said enough. You've not developed your point fully. I need to see some understanding of the technical processes at play here. Concrete streets are impermeable. Good. A technical term defining a process. And therefore, infiltration, another use of a technical term, cannot occur. And the impact of this is that surface runoff reaches the river more quickly. Effectively, what I've done is I've said what is happening in this section. Concrete structures are impermeable and infiltration cannot occur. And what is the impact of that? So surface runoff reaches the river more quickly. And there's your mark. And that's us at 6 out of 10. Just referring back to the question briefly, I'm only concentrating on this area where there's really rapid filling of the river. So I'm just going to keep doing that. There's no requirement for me to describe everything that's happening on the river, so I'm just going to concentrate on these reasons why the river is filling rapidly. And again, it's good to keep it simple. The date is quoted at the top, is in midsummer. So the ground may be baked hard and lack pore space. This is a term you may have forgotten. Pore space means the amount of gaps within the soil for water to infiltrate into. So, infiltration is limited and surface runoff is more rapid in reaching the river. The reason I focused on this as an example is because normally, not all the time, but normally, the SQA are kind enough to give you a date in the year. If the date is in winter, well, the ground may be frozen hard, and therefore it will be impermeable. If it's in summer, then the ground could be baked hard, and this means that it lacks pore space and can be and cannot be infiltrated. Either way, the date is a good way to, in a slightly more easy way, secure yourself some marks. I'm not going to go through every single long and short lag time reason because we'd be here for quite some time. Those are two good ones. What else could you talk about though? Well, for short lag times, the things that I would have revised and make sure I have an understanding of: 1. Concrete streets. If it's an urban area, then there are concrete streets, and it's just so easy to score a mark with that. Be aware that urban areas don't just have concrete streets, they also have sewers. And sewer systems speed up the movement of through flow, which is an underground movement of water. Both of these things explain rapid increases in discharge. The next thing that I would probably point to is the time of the year. That's nice and easy, and I've just explained it. Next up, basin size. If the basin is small, then there's less distance for the surface runoff to travel before it reaches the river. A simple explanation for why the river is filling up quite rapidly. As you'll be aware, weather and storms, they don't just happen in one location, they move. And so it is reasonable to suggest that the storm that took place, here's the rainstorm, remember, with the bars, this storm was directly overhead over the river, and of course that means that the water is going to make its way into the river much more rapidly and fill it up more quickly. So the location of the storm is quite important, and it's a not an unreasonable and straightforward explanation to offer for why the river is filling up quickly. The storm was directly overhead. It was over the river, so the water was falling directly into it. Geology. Some people can be put off just by the word, but really this just means the rocks underneath the ground, and some rocks are impermeable. So you just need to point out that the geology of the area may be impermeable. And this means that percolation cannot take place. It's a slightly more complicated one, so I've added a couple of extra words there. Here are 1, 2, 3, 4, 5 good reasons why lag times would be short. As I said, if you check your class notes, you'll find that there's actually loads. And if you look at the back of your hydrograph booklet, I think it's 4 pages from the back, you'll find a table that itinerizes all of the reasons. And that's a good place to go and revise. I wouldn't suggest you try and learn every single one of them. Instead, make a mind map like this and focus on the ones that you find easiest to understand. What if, though, you want to describe why the river is filling up slowly, why there is a long lag time? Well, first of all, it's worth pointing out that, of course, the basin could be a large basin. The storm could be located further away from the river within the drainage basin. The geology might be permeable, therefore percolation can take place. And of course there could be an absence of urban areas, which are therefore of course going to mean that rain can infiltrate into the soil and that will slow it down. All of this is kind of obvious, but just to be thorough, if we were to make a mind map of long lag reasons, there are some distinct things that most people kind of remember about long lag times. So again, here on this graph, where the river is filling up more slowly, this may be because when the rain was falling, it was falling over a forested area. Forests and other vegetation intercept rainfall. An interception slows the rainfall down in its journey across the land as surface runoff to the river. A nice, straightforward one. Farming. Specifically, ploughing. Where you plough fields, you increase the pore space within the soil. That means the gaps within the soil, and the soil is more capable of absorbing water. Also, the furrows, that's the ridges that ploughs make in the fields, they can often slow down surface runoff on their journey across the land. Indeed, farmers often contour plough. That means ploughing around the contours of a hill to deliberately slow the water as it flows across the land to stop the soil being washed away. Another easy one is just things like reservoirs. The presence of a reservoir in a river system obviously will slow down the movement of the water through the river. So the rain may be falling in one part of the drainage basin, but that rain is getting into the river system and getting entrapped in a reservoir before then making its way down the rest of the river course. That's going to slow it down quite markedly. Where else could water get stored and trapped? If the area is an area which involves mining, and this is West Wales, though you wouldn't need to be as specific as that. If the area is an area that has mining, then clearly underground huge holes underground are going to be a good way for water to get stored and trapped before making its way towards the river as through flow. Okay, so at this point in the lesson, what I've covered is what an answer needs to look like. This is important. Spend some time looking at this. Think how you would express yourself. Remember, try to be detailed and try to use the technical vocabulary that we've taught you. That's what we're looking for, okay? Notice that I am suggesting it could be an urban area. I can't deny that it could be an urban area, can I? And I'm relating that to rapid discharge. So you're being very specific. And then I've pointed out what's going to make that rapid discharge, what's going to make that water travel quickly. Well, the ground's impermeable, it cannot infiltrate. And what's the impact of that? This last bit of the sentence is important. What's the impact of what you're saying? Well, it means that surface runoff is going to reach the river more quickly. We've gone through a list of possible other short lag times, reasons that you could revise. Feel free to choose other ones. These are just the ones that I find particularly memorable. And also long lag time reasons. Don't try to remember every single long and short lag time reason because it's too much. Remember, this question is going to be about, 10, 11, 12 marks. Half of those marks can be scored through description. So make sure that you're good at this bit, the describing the graph, and then you can relax a little bit about this slightly more complicated explanatory stuff. And I think you should be reasonably and quite justifiably, given that 5 out of 10 can be scored through description, you could easily be targeting 8, 9, or even 10 out of 10 for a question like this. Okay, one last little reminder. Some key terms. You need to understand surface runoff. Surface runoff is the movement of the water over land. It is sped up or slowed down according to what surface it is running off over. Is the surface impermeable or is it permeable? Concrete and rock can be impermeable, but soil can be permeable. If it's permeable, then there's going to be a process of infiltration. If it's a permeable rock, this could lead to a process of percolation. Which just means dripping down through the rock. These processes will both lead to increased amounts of through flow and that is the underground movement of water reaching a river. Some other things to consider are words like interception, which is when vegetation captures water before it hits the ground and slows it down. By using these terms in combination, you'll make your answer far more powerful and you'll score marks much more easily. Surface runoff, permeable or impermeable. Is there infiltration or isn't there? Is there percolation or isn't there? And if there is infiltration and percolation, then there will be through flow. If there isn't infiltration and percolation, then there will be surface runoff. And interception is a useful term to know because it refers to how vegetation stops water hitting the ground and therefore slows it down. I suppose the only other term that I've used, which is vaguely complex, would be the use of the term store. A store of water is where water is gathered and trapped within the landscape, such as in a reservoir or in a mine system. Okay, so that's explaining a hydrograph covered. I'll be covering physical features in the next video.